Hello everyone, in this video we're going to talk about exponential functions. So an exponential function is a non-linear function, which means it's not going to be a straight line, of the form y equals a times b to the x, and we have a couple stipulations here. A can't be 0, b can't be 1, and b has to be greater than 0. Okay? One thing about an exponential function, it tells us as the independent variable x changes by a constant amount. So think the x values like 0, 1, 2, 3, 4, 5, 6. The dependent variable y is multiplied by a constant factor. So think 2, 4, 8, 16, right? Multiplying by 2, which means consecutive y values form a constant ratio, okay? So let's take a look at some examples here. First thing we're going to do is just identify an exponential function. So we've talked about linear functions in algebra. And so when we looked at linear functions, we found the slope, and if the slope was constant, then we said it was linear. Okay, so now when the slope was constant, that means our x values changed at a constant amount and the y values changed at a constant amount. Well, for exponential, the x value is still changing by a constant amount, but now the y value is being multiplied by a constant factor. So that's what we're looking for. Okay, so let's look here. On both of these, the x values here, we are just increasing by 1, right? Plus 1, all the way through. Now let's look at our y values. Down here we got plus 2, plus 2, plus 2, and plus 2, okay? So for this one, we're going to say this one is actually linear, okay? And our slope would just be 1, okay? Because our our slope would be 2, because we have, 10 minus 8 over 4 minus 3. Okay, so now let's look at the next one. X values are increasing by a constant amount, right? Just going up by 1. But now we go from 4 to 8. So you might be thinking, okay, plus 4. But then from 8 to 16, is that plus 4? No, right? So think, okay, now we're doing times 2, times 2, times 2, times 2. So now we have X values increasing by a constant amount, but we have the Y values increasing by a constant factor. Okay, so this one is going to be exponential. Okay? All right, now let's talk about evaluating exponential functions. When we're looking at an exponential function, we see our exponent is our variable. That's what gives us an exponential function. So on these two, they're just giving us a value for x to plug in for the exponent. So here we're going to say y equals negative 2 times 5 to the third power, or 5 cubed. So a little bit about order of operations. We're going to apply that exponent first. So 5 cubed is 125. Now we can multiply and we get negative 250. All right, for the next one, x is negative 2. So now we have y equals 3 times 0.5 raised to the negative second. Okay, so now we have to know how to handle a negative exponent, right? So remember, we have a video on exponent rules. Check it out in the top right-hand corner right now. So what we're going to do with this negative exponent is it's going to cause us to flip what's inside the parentheses. So 0.5 is like 1/2, right? So now I'm going to say 3 times, and instead of 1/2 to the negative second, we're going to flip 1/2. It's going to become 2. And once we do that, it makes that exponent become positive. So now we have positive 2. Okay, so now we have 3 times 4, and we get 12. All right, let's talk about how to graph exponential functions. So the graph of y equals a times b to the x is a vertical stretch by a factor of the absolute value of a, of the graph of the parent function y equals b to the x. When a is less than 0, the graph is also reflected in the x-axis. Okay, so a is less than 0, that means a is negative. We've seen that before when we talked about transformations. If our stretch or shrink has a negative with it, that's also implying a reflection. Okay, so you can check out the transformations video in the top right-hand corner if you want to review that now. The y-intercept of the graph of y equals a times b to the x is a. Okay, so a couple of things that we need to note about this equation. A is our y-intercept, okay? B is what we are multiplying. Basically, it's our constant factor. So if I go from 0, x value of 0 to x value of 1, what did we multiply by on our y values? That's what b is, okay? All right, so when we look at graphing, we could have essentially 4 different types of exponential functions. The two that we have in blue here, these two right here, that is when a is greater than 0. In other words, there is no reflection taking place. The two that are red down here at the bottom, that's when a is less than 0, so that would be there's a reflection taking place, okay? All right, so now let's look at the difference here. When b is greater than 1, when b is between 0 and 1. So if b, the number that is our factor, if that is greater than 1, then our graphs are going to approach the x-axis on the left side of our graph, okay? Because these exponential functions, they will approach the x-axis, but they will not cross it, okay? They approach it, but they won't cross it. Now, if b is between 0 and 1, then that means we're going to have some kind of fraction, right? So if we have a fraction and then we're raising it to an exponent, that's actually going to get smaller, okay? So that's going to cause our graph kind of to flip a little bit here, and it's going to mean that our exponential functions are approaching the x-axis to the right or with positive x values, but once again, not approaching it, okay? Or approaching it but not crossing it. All right, so let's look at a couple examples. This says graph y equals 4 times 2 to the x power, and compare the graph to the graph of the parent function and describe the domain and the range. So one thing about graphing, make a table of values to help us. Okay, so let's start off with -2, -1, 0, 1, and 2. And we're just going to plug these values in for x up here. Okay, so if I plug -2 in, and I do 2 to the -2nd power, that's going to become 1 over 2 squared, which is 1/4. And then we're going to multiply it by 4, right? So now we get a value of 1. Okay, so now if we do 2 to the negative first, that's going to give us just 1/2. We're going to multiply it by 4, and we get 2. Okay, now we're going to plug in 0, so 2 to the 0. We learned anything to the 0 power is 1. 1 times 4 is 4. 2 to the first power is 2. 2 times 4 is 8. 2 squared is 4. 4 times 4 is 16. Okay, so now we have basically 5 points that we can plot. Okay, so we're going to say, I'm going to start with 0, 4. Okay, why are we starting with that? Because that's our y-intercept. Remember, A is our y-intercept. So then we have 1, 8. We have 2, 16. And now going to the left, we have -1, 2. And we have -2, 1. Okay, so now we can draw our smooth curve going through our points. And we want it to approach the x-axis but not cross it. Okay? And so now we have our graph right there. Another thing that we can look at, right, we could say plot the y-intercept because A is 4. And then remember, B, this number in the parentheses, is what we're multiplying by. So when I go from x value of 0 to x value of 1, I multiply 4 by 2 to get 8. When I go from x value of 1 to x value of 2, I multiply 8 by 2 and I get 16. Okay? All right. Example 4. Y equals -1/2 to the x power. Compare the graph to the graph of the parent function, describe the domain and the range. Okay, once again, we're going to make a table. So let's say -2, -1, 0, 1, and 2. All right, now once we plug in, let's go 1/2 to the -2nd power. Okay, that's going to cause that to flip, remember? So this is going to be actually 2 squared, which is going to give us 4. And now we're going to make it negative, so we get -4. Okay, now we're going to do 1/2 to the -1st power. So that's going to become 2 to the 1st, which is 2. Make it negative, so -2. All right, then we have 1/2 to the 0 power. Anything to the 0 power is 1. Make it opposite, so -1. 1/2 to the first power is just 1/2. Now we make it negative, so we get -1/2. 1/2 to the second power would be 1/4. Make it negative, and we get -1/4. Okay, so now we can plot these. I'm going to start with 0, -1. Right, because once again, that was my A value, which is my y-intercept. Now I'm going to go to -1, -2, -2, -4, 1, -1/2, and 2, -1/4. Okay, so once again, we can draw our curve now through our points and then approaching our x-axis but not crossing it. Okay, so we can see a couple things. There was a negative involved, so we reflected over the x-axis. And now our graph is approaching the x-axis on the right side because our b value was between 0 and 1. Okay? All right, so now let's compare to the graph of the parent function. So in this one, all we had was a reflection over the x-axis of our original parent function, which would just be y equals 1/2 to the x. And now let's talk about the domain and the range. So the domain, that's left to right. So we're going to say all real numbers. That's what that symbol is, all real numbers. And for our range, notice that we have all values below 0. So we're going to say y is less than 0. Okay. All right, last one we're going to look at. Graphing exponential functions with transformations. Okay. So to graph a function in the form y equals a times b to the x minus h power plus k, begin by graphing y equals a times b to the x, and then translate the graph horizontally h units and vertically k units. Okay, so this is almost like vertex form, but it's not. We don't have a vertex on an exponential graph, so we don't call it vertex form. But h and k still represent horizontal and vertical translations, just like we looked at in our linear transformations video. So we're going to start by graphing just y equals 4 times 2 to the x. Okay, so if you notice, this is the one we did in example 3. So we're going to start off by graphing our y-intercept, which is 0, 4. Now inside here, this is our factor. B is our factor. That's what we're multiplying by. So if I have 0, 4, when I move over to 1 on the x-axis, I do 4 times 2, which is 8. When I move over to 2, I do 8 times 2, and I get 16. So if I were to go left, if I move to -1, then we would be at a +2, and -2, we would be at +1. Okay, so now we can make our curve here through our points. Once again, approaching the x-axis but not crossing it. Got a little wiggly there, sorry about that. Okay, so now we can look at h and k and we can move our points. Okay, so this says x minus 3, so that means we're going to go right 3, and then +2 means we're going to go up 2. So I'm going to move just these 3 points here. I'm going to move them right 3 and up 2. So start my y-intercept, 1, so right 3, so each of these lines here is 2, so we're going to go right 3 would be to there, and then we're going to go up 2, which would put us right here. Okay, so this point here that has an x value of 1, we're going to go right 3, so it's going to give us an x value of 4, and up 2. Okay, and then we'll move 16. We're going to go right 3 and up 2. Okay, so we get that point right there. And let's look at our point that's on -1, 1. So right 3 is going to get us to 2, and up 2 will get us to 4. Okay, and then we'll move our point here that is at -2, -1. So -2, -1, we're going to go right 3, which would get us to +1, and up 2, which would get us right here. Okay, all right, so now when we make our curve here, we can see a couple things. All right, so domain and range. Notice the domain, we're still all real numbers, right? We're moving left and right forever. But now, notice our range. Our range was right here, y is greater than 0. But we moved our points, all of our points up 2. Okay, so now we're going to say our range is y is greater than 2. And once again, our exponential function will approach y equals 2, but it will not cross it. Okay? All right, so that's a little bit about exponential function.